Hi there. In this clip, we'll see how we can harness the power of all those exponent rules like multiplying or dividing to help simplify a larger problem. Essentially, what we're going to do is take a big mess of variables and exponents and clean them up using the exponent rules. So I'll demonstrate one problem here on the left, and then stick around because later on the right you can try your own problem, and I'll get you to try it on paper and I'll post the solution when you're ready. So let's go ahead and have a look at the first problem that I'll solve. We're being asked to simplify this. So right now it looks like a bit of a mess. I see some A's and B's and brackets and exponents and some division, and hopefully by the end of it it's going to look a lot nicer to work with. But where do I start? Well, if I think back to BEDMAS, that'll help me out in this problem. BEDMAS, brackets, exponents, division, multiplication, addition, subtraction. I'm sure you've heard it before, but if not, that's just the order that we're going to try and solve this problem in. So brackets, I look inside the brackets, and I don't really see much I can do here because this A and this B don't match. The bases aren't the same, so I can't use any exponent rule inside the bracket. How about this bracket? Well, I have the same problem. I have an A and a B. The bases don't match. So there's no real way I can push these together using an exponent rule. So the B in BEDMAS is gone. How about E, exponents? Well, there's definitely a lot of exponents. And I see a 2 on the outside that I could probably bring in here, and a 3 that I could probably do some work with as well. So let's go to step 1 where we'll work with the exponents. To simplify this, I'm going to use the power of a power rule. I have a 2 on the outside, and it's a power of this power and this power. So how do I do this? Well, the rule says that I have to multiply the exponents. So I'm going to end up with A 3 times 2. This 2 is trying to get in, which makes a 6. And then B, I have 2 times 2. That's going to make a 4. And then I'll add my closing bracket right there. Now let's look at the second piece. I would call this part the second piece where there's a division. This 3 would like to get in to the bracket as well. It's also going to use the power of a power rule. Even though there's no exponent on the inside, there really is. There's an imaginary 1. They just don't write 1 exponents because typically it doesn't change the variable. So I have a 1 times a 3 here for A and a 1 times a 3 here for B. So I can rewrite that like this. I'll say A, and now 1 times 3 will make a 3. And it's divided by B to the 3. We did the same thing for the top and bottom. So remember that tip. If you have a division inside of a bracket with an exponent on the outside, you can split it up. Top and bottom both have a 3 exponent. Okay, that's my E done in BEDMAS. So let's move on to the D in BEDMAS, which is division. That's the next step. Combine into one fraction and divide. For division, this would probably look a lot easier to work with if it was all one fraction. So I'm going to rewrite it to look something like this. I'm going to remove the brackets. So I have the top like this, and then the bottom would just all be B to the 3. And the reason I do that is so that now the division sort of pops out. I can see it. I know I need matching symbols, matching bases for the top and bottom to use the division rule for exponents. Well, I have a B on the top here and a B on the bottom here. So the rule says I just subtract the exponents. So I'll have 4 minus 3, which is 1. So to rewrite that, I'll have A to the 6, and then B. There'd be a 1 here, but I don't bother to write the 1 exponent, and then A to the 3. There is my D in BEDMAS done, the division. Let's move on to M, multiplication. Well, we're getting really close to having this all cleaned up, all simplified. So for multiplication, I need to use matching bases. Do I see any symbols that match? Well, this A and this A both match, so I can multiply them together. The exponent rule says that I just add the 2 exponents. So 6 and 3 will make A to the 9. And finally, I have a B at the end. And that's as far as I can take that because the 2 symbols now don't match. One's A, one's B. So that's my final answer, all simplified as far as I can go. Now if you look at where we finished compared to where we started, it's a lot more simple to work with. And let's see how well you do with your own problem. So grab some paper and a pencil and try this practice problem on your own using the steps I showed you on the left. Let's see if you can simplify this. Okay, I'll post the solution when you're ready. Simplified, your final answer is 3 times b to the 4. A lot nicer than this big mess that it starts out with. So what we did first is power of a power rule. We brought the 4 into the bracket. Remember, the 4 goes to the a and the b to make a to the 4 times b to the 4. And then down below we did the same thing as well. The trick is this 2 exponent applies to the -1 in front as well as this exponent. So we have -1 squared to make just a 1 right here, and then a to the exponent 4. Finally, we divided both a to the 4 from the top and the bottom. They cancel to make a 1, leaving just a 3 and a b to the 4 behind.